Alright guys, so we want to check our do first. The first thing that they asked us to do was to use the calculator and match this function with the graph. So when you go to your calculator, you get into a new document and add in a graph. The first thing you're going to do is 2 raised to the x power. If you need to raise something to the x power, you're going to use this button right here, and it will allow you to raise to the x variable. So 2 to the x variable. You hit enter, and you can see that it's going to go through the point 0, 1, and then 1, 2. 0, 1, and 1, 2. The only graph that does that, goes through 0, 1, and 1, 2, is graph A. A couple of things that you want to notice about this. One, you want to label this coordinate point right here, 0, 1. You also want to label this coordinate point right here, which is when x is 1, y is 2. When x is 1, y is 2. Y equals 2 to the x. And that makes sense too right over here. If you put a 1 in here, 2 to the first power is just 2. So every time x is 1, you're just going to get this base right here. You're going to get 2. 4 to the x power. If we go back to our handy calculator, we're going to go 4 to the x power. And that'll look like this. You can see that it's still, like the other one, it's going to go through the point 0, 1. But it will also go through point 1, 4. And that makes sense for us here. 1, 4. Because if we have a function y equals 4 to the x, and when x is 1, 4 to the first power, what is 4 to the first power? Well, it's just 4. So that's why this coordinate point is going to happen. So you're going to use this base, this 4 right here, is going to go right over here to the y. Alright, now let's take a look at the next function over. It says 1/2 x, 1/2 to the x power. So we will do 1/2 to the x power. That comes out like this. I can see that on this side, if I go to -1, it's going to be -1, 2, and if I go over to +1, it's going to go up to 1/2. So I'll look for where I have a graph that is at -1, 2, 0, 1, and then 1, 1/2. And we're going to get that. This is graph 3. And this graph, it says f of x is 1/2 to the x. And again, this 1/2 is what we put right here in the y side. Alright, last one. We're going to do, this is graph 4, because it's the only one we haven't used yet. And let's see what coordinate points it goes through. We can probably predict out already, since we know the pattern, but we'll put in 1/3 just to verify. Cool. It still goes to the point 0, 1. And notice 1, 2, 3, 4. They all go through that point. And then we're gonna see, okay, -1, 3, 1, 2, 3. -1, 3 is one coordinate point, and then also 1, 1/3 is a coordinate point. So we have this one over here, which is 1, 1/3. We got that because f of x is 1/3 to the x. When we substitute in 1 for x, it's 1/3 to the first power. So if you go to your calculator and you do 1/3 and you raise it to the first power, you're going to get 1/3 back. The same thing happens with your y-intercept, and that's why you have the same y-intercept every single time. Because when you put a 0 in for x, for example, in this problem, 1/3 to the 0 power, 1/3 to the 0 power, anything that you put to the 0 power, it doesn't matter what number you put in here, 1/3, 3, 60,000, 2 million, if you raise it to the 0 power, it will always come back as 1. And that's why every single one of your graphs has this intercept 0, 1. Because every time you raise this to the 0 power, it makes all of this 1. Okay? So So that's a rule right there for us that we're going to get a little bit further into. When you look at the questions on the back to finish up your do first, what point do all of these graphs have in common? Well, we just talked about that, right? It's 0, 1. That is the y-intercept. You know, where the graph crosses the y-axis. How do you think the point on the graph where x equals 1 is related to the equation? When we look at x equals 1, you can see that every time x equals 1, y will equal the base. So here, when x is 1, y should be 2, y should be 1/3, y should be 1/2, y should be 4. So when I write my sentence, I can say, when x is 1, y is the base. Okay, and this word, the other classes, we spent a lot of time making sure that we understood what a base is. The base always looks like this, the exponent always looks like this. So now you can tell the two apart. You're going to have base raised to an exponent. An example of this would be 2 raised to the x. 2 is your base, x is your exponent. Alright, if they give you a function, like that, what can you tell me about the y-intercept? Well, we know that all graphs that are exponential will have this y-intercept. So y-intercept, if we have f of x is b to the x. So when x is 1, we're just left with b. Excuse me, when x is 0. Okay. The y-intercept is when x is 0. So f of 0 is b to the 0. What is anything to the 0 power? It's just 1. So the y-intercept happens when x is 0 and y is 1. It says, what about the point where the graph is x equals 1? So f of x equals, here's where x is 1. Anything to the first power is just, again, that base. And this is saying when x is 1, y equals the base. And we saw that up here on part 2. When x is 1, y is the base. Domain and range. Alright, let's say that this is a regular growth graph. And it looks like that. We're growing like this. This could be a virus that's replicating. We start out with one virus and then it duplicates, so now we have 2 viruses. Each of these viruses will duplicate, so now we have 2, now we have 4. All of the 4 will duplicate, so now we have 8. All of the 8 will duplicate, so now we have 16. All of the 16, so now we have 32. All of the 32, so now we have 64. So you can see the growth there. The domain, see these arrow markings? That means that your domain is going to go from negative infinity all the way up to positive infinity. Another way to write that is just domain is all real numbers. The other thing that you can write is the range. Range is, you see how on this part of the axis, the graph is above the x-axis. And it will always be. At no point are you going to have negative amounts of a virus in your body. You'll have something that is bigger than 0. Alright, so your range is any number that's bigger than 0, and your domain is all real numbers. Equation 1 and 2 are exponential growth, 3 and 4 are decay. What do they have in common? Alright, so 1 and 2, they said were growth. 1 and 2 are these look like growth. I know they're growth because when I put my pen down on the arrow markings, I have a positive slope of my line. Positive. That means growth. You can see the difference over here. When I put my pencil on my arrow markings, the slope of the line is negative. So this is not a exponential growth. This is exponential decay. What do we notice about the bases? Well, if it's exponential growth, you can see the base here is 2. You can see the base here is 4. 2 and 4 are your bases. Then over here, let's look at the decay side. On the decay side, when you look at your bases, you've got 1/3 for a base, and over here, you've got 1/2 for a base. So what can we pull out of here? Well, if it's going to be exponential growth, we're looking for a number bigger than 1. If it's going to be exponential decay, we're looking for like a fraction between 0 and 1. So let's write that down. We're going to put in growth. Your base needs to be bigger than 1. That's exponential growth. And that's our first key point for today. Our second key point, and this is a biggie, the decay side. Decay happens when the base is between 0 and 1. Alright, so in some of the other classes what we did is we just listed out some examples of what bases would look like. So this is a growth base, and this is a decay base. Ask yourself, what is an example of a base that is growth base? So when I think about this, a growth base example for me, y equals 3 to the x. It fits all the numbers. It's a base is bigger than 1, and we're raising the x to the exponent. If I wanted to do a decay form, I could do y equals 1/3 raised to the x. So think about some of the other examples that will fit in here. Maybe you chose 4x and y equals 1/4 to the x. Maybe you chose 2 and you put y equals 2 to the x, y equals 1/2 to the x. Just remember that you know the difference between growth and decay by if the base is going to be a number bigger than 1 or between 0 and 1.